Hello, and thanks for using TickBoom. In this video, I want to take a look at another interesting question that's come up in my Math Curriculum 1 subject that I'm doing as part of my Master of Teaching. So this question hasn't been sent through by a student, as they normally are. It's a question that has been given to me, where I'm the student. And it's kind of targeted at the Year 7 or Year 8 level, albeit it would be a challenging question for those grades. So it's kind of like an extension question for some pretty switched on Year 7 or 8 students, or perhaps you could do this question at the Year 9 or 10 level, and perhaps at that level it would be not that difficult, just a kind of stock standard question. So the questions are requiring the ability to find patterns. So we're given this set of 3 images made up of circles, and the challenge is to work out the pattern of growth. So this is kind of like a very gentle introduction to the idea of sequences, but without using that jargon, and it's really just seeing how does the pattern of numbers grow. So there's a series of questions that I'll work through and kind of share how I tackled this question. We didn't end up going through this in class. It was kind of given as homework for us to do and then share our thoughts in class. But for that particular class, we just ran out of time, so we never got to this, which was unfortunate. But I thought it's such an interesting question and a really good one to give to students that I thought I'd share how I tackle it. Now, if you want to have a go at this yourself before looking at the way I approach it, feel free to pause. I'll kind of put a little gap in the video so that you can safely pause, have a go at it yourself, and then come back and see whether the approach you took is the same as the approach I took, because I'm pretty sure there's probably many ways you could spot the pattern here. All right, so if you did have a go at this question, hopefully you were successful and you could spot the pattern. What I'll do now is I'll share the way I thought about it. And the first thing I did, the first kind of element to this that I spotted is, maybe I'll just get another color here. I noticed that all of these sets of circles could fit within a square. And so step 1 for me was just to kind of highlight that square and then think about, well, what is the size of that big square, and is it a function of the kind of n or the number, the term in the sequence? And so here we've got a square that's 3 by 3, so that's kind of n plus 2. Here we've got a square that's 1, 2, 3, 4, 5 by 5, so that's n plus 3. Here we've got a square that's 1, 2, 3, 4, 5, 6, 7 by 7, so that would be n plus 4. And notice that it's n plus something squared, and that something is always growing by 1, plus 2, plus 3, plus 4. So we can kind of think of the big square as n plus bracket n plus 1 all squared, and I'll write that out when we get to kind of converting this into a formula. But before I do that, some of the other things I noticed just visually is that there's always a center square. So here we've got a center square of size 1. Here we've got a center square that's 2 by 2. And here we've got a center square that's 3 by 3. And so I noticed there that center square is following a pattern where it's always the number n squared. So 1 squared, 2 squared, 3 squared, and so on. So that kind of, I thought, might be helpful for our pattern spotting. Now, the next thing I noticed, maybe I'll use green here, is that there's also, maybe I'll start from 3 and work backwards, there's a kind of partial square over here at the bottom right hand side. So here we've got a 3 by 3 square with 1 square missing. Here we've got a 2 by 2 square with 1 square missing. And here it's kind of tricky to visualize, but we've got a 1 by 1 square with 1 square missing. And so this bottom right one we can say is always kind of like the center square, n squared minus 1. So that's kind of what I spotted here, and that's a bit trickier to spot because in n is equal to 1, it kind of means there's nothing there. But I think it works if you kind of start from n is equal to 3 and come backwards. It's kind of easier to figure that out. Now the last element of the pattern is what's happening in the top left corner. So here we've got just a 1 by 1 square up in the top left. Here we've got, again, a square, in this case 2 by 2 with 1 missing. And here you can kind of picture this as, again, a square, in this case 3 by 3, but with 2 missing. And so again, we can kind of convert that into a pattern where it will be n squared minus, and in this case it would be 2 missing, 1 missing, nothing missing. So it's kind of n squared minus n minus 1 squared. And again, that's a trickier one to spot, but for me, kind of drawing it up visually helped me to kind of piece together, well, what am I actually seeing with these circles? Well, they're really just a kind of how much of a square is or is not filled with circles. And so here now, for me, I kind of got to the point where I could say, well, the pattern that I think is emerging in terms of n, so I'll write this as a function of n, but first I'll just write it conceptually. It's going to be the big square, so I'll just write big square, how much circles would fit in the big square, which is kind of this outside square that I started with. And then we're going to subtract a whole bunch of things. So let's say we'll subtract the center square, which I've got here in red. I'll just call it the square in the center. And then next I'll subtract the one that I've got in green, which is minus the square at the bottom right. And then finally we subtract these top left ones, the square at the top left. And I think if I can get all of these elements in terms of n and then simplify, we should end up with a formula for the pattern, which then will let us answer the various questions. Like, I think in particular there was a question as to what would be the number of circles at n is equal to 10. I think a lot of the questions were centered around that. So let's go and have a look. So converting this into n's, the big square I noticed was, I'll just write this in brackets, n. So we start with n, and then we add to that n plus 1. And then that is all squared. So here it would be 1 plus 2 squared, which gets us 3 squared. Here it would be 2 plus 3, which gets us 5 squared. And here it would be 3 plus 4, which is how we get our 7 squared. 1, 2, 3, 4, 5, 6, 7. So that's kind of how we get our starting point, our big square. Now in terms of what we subtract, I'll just do all this in the one color now. The center square, notice, was always just n squared. So it's going to be minus n squared for our center square. So that's easy enough. If we think about our bottom right now, that we worked out was minus, and I'll put this in brackets. This was always our n squared and then subtracting 1 off the n. So this would be minus n squared minus 1. And then the last thing we subtract is our top left. And that one we noticed was n squared minus, so it wasn't the full square, but minus, in this case it was a 2 by 2, in this case a 1 by 1, in this case minus nothing. So it's kind of the 2 by 2 is 3 minus 1. The 1 by 1 is 2 minus 1. So it's n minus 1 squared. Drops off what we're subtracting in the top left. And that kind of makes sure that we don't remove things twice, because a lot of these squares we've already subtracted when we were dealing with the center square. So I think that's the crux of it. So now we just need to kind of expand and simplify where possible. So if I start with this, maybe I'll just clean some things up a bit. So this first bracket will be n plus 1 would be 2n plus 1. So I'll just call that 2n plus 1 squared. We'll have minus n squared, and then if I expand this minus through, we get minus n squared plus 1. And then here, if I clean this up a bit, we'll have minus, and I'll keep the bracket, so we'll have our n squared, and here minus, and if I expand this square, it would be the first one squared, minus 2n plus 1. So now if I expand this, the first one squared here would be 4n squared, and you've got to be careful to square the whole thing, plus twice the product, so that would be plus 4n plus 1, minus n squared would be minus 2n squared, and then we've got our plus 1, and here we'll have minus, and I'll keep this bracket again, it'll be n squared minus n squared plus 2n minus 1, and you've got to be really careful with your minuses here. But that means these two n squareds will disappear, and what we end up with is 4n squared plus 4n plus 1 minus 2n squared plus 1, and then I'll put this negative through, so we get minus 2n and then plus 1 again. So now cleaning all this up, we'll have 4n squared minus 2n squared will give us 2n squared. So there, that's those two bits done. 4n minus 2n would be plus 2n. So that's those bits done. And then plus 1 plus 1 plus 1 gets us plus 3. Sonic boom! So that there, I think, is the formula for getting the number of circles for any value of n. I think this formula will give it to us. So hopefully, if you did take the time to try and work this out, you got to a similar thing. There's definitely no need to have done it exactly the way I did. I think there's plenty of ways you could tackle this, but hopefully you end up, in terms of where you simplify to, you end up in the same place, which is you take n and square it, and then times it by 2. Then you take n and times it by 2, and then you add 3, and then that gets it. Now there's a few things we can check. We can check if we put n is equal to 1, n is equal to 2, and n is equal to 3, do we get the right answer? Because we can obviously verify those just by counting. So let's do that. Let's check what happens when n is equal to 1. Well, in that case, I think the number of circles, at least according to this formula, would be 2 times 1 squared plus 2 times 1 plus 3. So what is that? It's 2 plus 2 plus 3 would be 4 plus 3 is equal to 7. And let's count. 1, 2, 3, 4, 5, 6, 7. So that's good. That's a good start. I'll just move my calculator. I might need that later for higher values of n. But I might turn over now, and let's test n is equal to 2. So when n is equal to 2, we think the number of circles should be, so it'll be 2 times 2 squared plus 2 times 2 plus 3. So 2 times 2 squared plus 2 times 2 plus 3. So what's that? 2 times 4 is 8. 2 times 2 is 4, plus 3. So what is that? 8 plus 4 is 12, plus 3 would be 15. Let's go count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so that's another good sign. And let's do our final check. When n is equal to 3, the number of circles would be 2 times 3 squared plus 2 times 3 plus 3. So that's going to be 2 times 9 is 18. 2 times 3 is 6 plus 3. So 18 plus 6 would be 24. And 24 plus 3 would be 27. So let's go count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. All right, so that, I think, should give enough comfort that the formula we've landed on does correctly reflect the pattern. So now we can start thinking, well, what about when n is equal to 10? So, you know, rather than trying to manually draw up the pattern and try and expand it, now we can save ourselves the time and just plug it into this formula. So when n is equal to 10, the number of circles, I believe, would be 2 times 10 squared plus 2 times 10 plus 3. 2 times 10 squared is 100, so that's 200, plus 2 times 10 is 20, plus 3. That's going to be 223. Easy enough. Still haven't needed my calculator yet, even though I'm quite famously bad at mental arithmetic. I think so far it's been not too troublesome. And then I think the next one was n is equal to 100. So let's have a look. When n is equal to 100, what do we get? So the number of circles is equal to 2 times 100 squared plus 2 times 100 plus 3. So 100 squared would be 10,000. So that's going to be 20,000. And then 2 times 100 is 200 plus 3. So here I think we're going to get 20,203. So n is equal to 10, n is equal to 100. There, that's how we'd approach those two. Now, I think the last two that we want to look at to kind of work through all the elements of this question are kind of the initial cases. So what happens when n is equal to 0 and then n is equal to -1? So for us, if we're using our formula, I think when n is equal to 0, the circles would be 2 times 0 squared plus 2 times 0 plus 3, which just gets us 3. And then finally, when n is equal to -1, the number of circles would be 2 times -1 squared plus 2 times -1 plus 3. And you just got to be really careful with your negatives here, because -1 squared would be 1. So this is going to be 2 minus 2 plus 3. So we're going to get 3 again. And yeah, that's kind of the question done. I think the last two bits were asking, well, what's the general formula? But I've kind of just tackled that to start with. So yeah, really interesting question. I think if you were to give this to year 7 and 8 students, I think it would be quite difficult for that level. I think your very talented students might be able to grapple with this and kind of work it out. But you probably wouldn't be surprised if a lot of your other students might not be able to spot this pattern, because it's there's a few unintuitive elements to it. But the hope is, if you were to say give this to year 9 and year 10 students, perhaps their familiarity with pattern recognition might be a bit better. So hopefully their ability to spot the pattern might be a bit more advanced, and then they hopefully would be much more comfortable with the algebra that they're dealing with. So yeah, there you have it for that question. Hopefully you found it interesting. Hopefully if you gave it a go, you were able to get there too. If you did get to this place but using a different approach, I'd be really interested to hear it. So feel free to share in the comments, especially if you think there's a better way, like a quicker way. But in any case, even if it's not quicker, if it's just different, I'd really be interested to know. If you did find that explanation helpful, please be sure to give the video a like. And if you're someone who wants to keep their finger on the pulse with the kinds of questions that other students are struggling with, please be sure to subscribe to my channel so that you can stay in the loop. All right, tick boom.